What's going on, everybody? Got another video here for you. This is on Fourier series. And I'm guessing it's going to be a long one, so let's get started. All right, so a Fourier series for a function f of x is f of x is equal to a0 plus a1 cosine x plus a2 cosine 2x all the way to a sub n cosine nx plus b1 sine x plus b2 sine 2x all the way to bn sine nx. Now, the thing we have to do here is we've got to find a0, a1, a2, and so on, b1, b2, and so on. So how do we find those? Well, a0 is 1 over 2 pi times the integral f of x dx from negative pi to pi. And a sub n, so a0, that's how we find this constant term here. And a sub n, that's how we find the a1, the a2, and so on. That's 1 over pi times the integral f of x cosine nx dx from negative pi to pi. That's how we find the coefficients of cosine. And then to find the coefficients of sine, the b1, b2, and so on, bn is 1 over pi times the integral f of x sine nx dx from negative pi to pi. So it's tedious on how we find these things. So I'm gonna work the problems one way, and then we're gonna gradually get to where it's not gonna take as long. Okay. So let's go ahead and look at our first example. So they want us to find the Fourier series for the square wave function f of x is equal to -1 if x is between negative pi and 0, and 1 if it's between 0 and pi. Now, later on in the video, notice this Fourier series. This is for when we're from negative pi to pi. You see, like right here, negative pi to pi. We're going to work several examples with this, and then we're going to get to some functions here where it's not pi. And so this formula up here is a little different. So, and I'll write it down. So, all right. So let's go ahead and get started. So first, we need to find a0. So a0 is equal to, so that's going to be 1 over 2 pi. Now look at this. It's 1 over 2 pi times the integral from negative pi to pi times the integral of the function from negative pi to pi. Now notice how the function changes. You see that? From negative pi to 0, it's -1, and from 0 to pi, it's 1. So that means we have to split this up into two integrals. All right, we're not just going to go from negative pi to pi. So this is going to be times the integral of negative pi to 0. And what's our function? What is f of x? Well, it's -1. So that's -1 dx plus, and then we've got 1 over 2 pi from 0 to pi. So we got to do this part, and that's 1 dx. All right. And so here we get 1 over 2 pi, and that's going to be times negative x from negative pi to 0 plus 1 over 2 pi times x from 0 to pi. Okay, so all I did is I just integrated each one of those. And so this is going to give me 1 over 2 pi times -0 minus -pi. Well, I'm sorry. That's not what it's going to be. Well, I'm going to write it all out. It's going to be negative negative pi. All right, so we plug the negative pi in for x, so that's a negative negative, and then plus 1 over 2 pi, and that's going to be pi minus 0, which you can see this is negative. All right, so this is going to be a positive, and that's going to be a minus, so that's negative 1 over 2, negative 1/2, because the pi's cancel, and then the pi's cancel here, and that'd be plus 1/2, which equals 0. So you can see our constant term in this one is 0. All right, now let's go ahead and find the a terms. Now I'm gonna work one of them. I'm not gonna do all of them. But if we find a1, okay, so you see we've got to find a1, a2, and so on. So let's look at a1. So it's this one right here. Okay, now remember, n is 1, so that's just going to be cosine x. All right, and so that's going to be 1 over pi times the integral negative pi to 0. Okay, so we got to split it up again, and it's the function. So from negative pi to 0, it's negative 1. So that's going to be negative 1 times cosine x, because n is 1. And so that's just going to be negative cosine x dx. Plus, and then we've got to go from 0 to pi. I'm sorry, I left off the 1 over pi. We've got to go from 0 to pi, and our function is 1. So it's 1 times what? Oh, I'm sorry, not sine. It's cosine x. All right, so where did the cosine x come from? Well, that's from plugging 1 in for n. 1 times x is x. And then we've got the negative 1 for this one, and the positive 1. See, f of x is positive 1 from 0 to pi, so that's 1 times cosine x dx. And when you integrate this thing, you're going to get 0. Okay? So let's just do this real quick. That's 1 over pi times negative sine x from negative pi to 0 plus 1 over pi, and that's going to be sine x from 0 to pi. Now you can see we've got to evaluate the sine function at 0, and we've got to evaluate the sine function at negative pi. We've got to evaluate this sine function at pi and the sine function at 0. Well, what happens when you plug 0 in? Sine of 0 is 0. What happens when you plug the negative pi in? Well, the sine of negative pi is 0. So this whole thing's going to 0. This is 0. What happens when you plug pi in? You get 0. What happens when you plug 0 in? You get 0. So this is 0 also. So this is 0. And matter of fact, A2 is also 0. All the values that we calculate are going to be 0. Okay? So that means we're not going to have, see, since all these A1, A2, A3, all the way to A sub n, since all of those are 0, we're not going to have any cosine terms in our Fourier series. Okay? And we're not going to have an A0 because... All right. So I had to pause the video, got a FaceTime call from the wife and daughter. They're coming back from vacation. So let's see, where was I? All right. So anyway, I was saying that all the A terms, A1, A2, A3, those are 0, and the A0, that's 0. So now let's look at the b, the b1, b2, and so on. So let's go ahead and find b1, and it's going to be the exact same thing that we did up here, except we've got the function times sine. Okay, so we're finding b1, so that's going to be 1 over pi times the integral negative pi to 0. All right, so that's going to be negative 1 times sine of x, because n is 1. And went from negative pi to 0, so our function is negative 1. So that's going to be negative sine x dx plus 1 over pi times the integral 0 to pi. I see we got to do this part now, so that's going to be our function 1 times sine of x. So that's just going to be sine x dx. All right. All right, so let's go ahead and integrate this. So that's going to be 1 over pi cosine x from negative pi to 0. And then the integral of sine x is negative cosine, so that's going to be minus 1 over pi cosine x from 0 to pi. And now we have to evaluate these. So that's going to be 1 over pi times cosine 0 minus cosine negative pi minus 1 over pi times cosine of pi minus cosine of 0. All right. And so this is going to give us 1 over pi times cosine of 0 is 1 minus, now the cosine of negative pi. All right, so remember this. Cosine of negative pi is equal to cosine pi. That's your negative angle identities from trig. Cosine's an even function. So the cosine of pi is negative. Whoop, let me change colors back. Cosine of pi is negative 1, so that's minus negative 1 minus 1 over pi times cosine of pi is negative 1 minus cosine of 0, which is 1. And when we do all those calculations, we end up with 2 pi plus 2 pi equals, I'm sorry, not 2 pi, 2 over pi plus 2 over pi, which is equal to 4 over pi. So there's your value for B1. Okay. So now we need to find B2 and B3. All right. So let's find B2. All right. So the way I'm working these right now, I'm working them the long way. Okay. I think it's good to do this, and then we're going to do it where we don't have to do as much work. All right. So now let's find B2. All right. So we've got 1 over pi from negative pi to 0 of negative 1 times, okay, so remember, we're using this right here, negative 1 times sine 2x, because n is 2 this time. So that's negative 1 times sine 2x, let me make that 2 better, 2x dx plus 1 over pi times the integral 0 to pi of sine, because that's our function is 1 times sine 2x dx. All right. Okay, now let's take this one right here. Let's go off to the side. Let's show the work on integrating this, and then we're not going to show all that work anymore. Okay, so I just want to show you what happens if we do sine 2x dx. Just integrate that. Don't worry about limits or anything like that. All right. So for this one, and you can do this one in your head by now. You should, but in case you can't, I'm gonna work it out and show you. And then from now on, from this point on, I'm not going to work it out. I'm not going to show all the steps anymore for integrating this. But you would use a u substitution. You would let u equal 2x. So du is 2 dx. So we've got a dx. We need a 2. So we would multiply by 2. That means we got to come out here and multiply by a half. So we get 1/2 times the integral sine, and in the place of 2x, we're going to put u. In the place of 2 dx, we're going to put du. And so that would be negative 1/2 cosine u plus c, which is negative 1/2 cosine 2x plus c. Okay, so what I'm getting at is, all right, up here, when we integrated sine x, we know the integral of sine x is negative cosine x. Okay, but this time we have a number in front of the x. Okay, see how we have this 2 in front of the x? So when you integrate that, yes, you can come over to the side and do the u substitution, but just remember, it's the integral of this. So the integral of sine 2x is negative cosine 2x, and then you need to multiply out here by the reciprocal of what that is. So in other words, let's just say you had sine nx dx integral, and you wanted to integrate that. Okay, n is just a number. So this would be negative cosine nx plus c, and then you would need to multiply by the 1 over n. That would be the antiderivative, the integral of sine nx. And cosine nx works the same way. If you had the integral cosine nx dx, well, what's the integral of cosine? Well, that's sine, right? And then you would have to multiply by the reciprocal, not a 2. You would multiply by a reciprocal of the number in front of x. Okay? All right. So now that we've got that established, that's going to make it a little easier on what all work we need to show in the video. All right? So we know how to do that. But note, if you can't do that, if you don't remember to do that, then you can do it using u substitution. Okay? All right. So here, I'm going to get what? 1 over, now I got to multiply by 1/2, right? So that's going to be 2 pi, right? Because we would have 1 over pi times 1/2, right? The 1/2 comes from the 2 here. And so that's 1 over 2 pi. And that would be times cosine 2x from negative pi to 0 minus 1 over 2 pi, because the antiderivative of cosine is negative. I'm sorry, the antiderivative of sine is negative cosine 2x, right? And there's the minus, the plus and minus make a minus, and we got to multiply by the 1/2. 1/2 times 1 over pi is 1 over 2 pi. And that is going from 0 to pi. All right. And I mean, and we didn't really need the parentheses there. You can put them or not, it doesn't matter. But anyway, we get 1 over 2 pi times cosine of, plug the 0 in, so that would be cosine 0, 2 times 0 is 0, minus cosine of, plug the negative pi in, that would be negative 2 pi, minus 1 over 2 pi times cosine of 2 pi minus cosine of 0. All right. And so what we get here, we get 1 over 2 pi. Cosine of 0 is 1. And remember, cosine of negative 2 pi is the same thing as cosine of 2 pi. And cosine of 2 pi is 1. So that's 1 minus 1. And then minus 1 over 2 pi times cosine of 2 pi is 1 minus cosine of 0 is 1. And this is all just 0. Okay? All right, now let's do B3. All right, so B3, that's going to be 1 over 2 pi. I'm sorry, 1 over pi times the integral negative pi to 0. So our function is negative 1 times what? Times sine 3x dx plus 1 over pi times the integral 0 to pi. And that's going to be, our function is 1. Remember, it's f of x times sine. So in this case, from 0 to pi, f of x is 1 times sine 3x dx. And then we need to integrate this. And so that's going to be 1 over pi. And then the antiderivative of cosine is, the antiderivative of negative sine is cosine. So that's going to be cosine 3x from negative pi to 0. And this, and then it's going to be 1 over 3 pi because we got to multiply the 1 over pi by 1/3. And then minus, the antiderivative of sine is negative cosine, so there's your minus, and that's going to be 1 over 3 pi sine 3x from 0 to pi. And then we need to evaluate this. This is going to be 1 over 3 pi times cosine, plug the 0 in, 3 times 0 is 0, minus, and then we've got cosine of negative 3 pi minus 1 over 3 pi times, oh, wait a minute, I'm sorry. You see this right here? That should be cosine. That's cosine. Don't know why I wrote sine. All right, and that's going to be cosine of 3 pi minus cosine of, plug the 0 in, that's cosine of 0. And so this is going to be 1 over 3 pi times, all right, so we got cosine of 0 is 1 minus, and then cosine of 3 pi is negative 1, minus 1 over 3 pi. This cosine of 3 pi is negative 1 minus cosine of 0, which is 1. And this ends up being 2 over 3 pi plus 2 over 3 pi, which is 4 over 3 pi. All right. And so there you go. Okay. All right. So in this problem, we can actually kind of see a pattern. So B1 is 4 over pi. Let's just write that down. B1 is 4 over pi. B3 is 4 over 3 pi. And B2 was 0. All right. So in this problem, we could actually say in general, if n is even, then Bn is 0. Okay, all the B terms are going to go to 0. B1, B2, I'm sorry. All the B terms with an even n are going to go to 0. B2, B4, B6, B8. Okay. And if n is odd, Bn, now you know I see a pattern here. See here, n is 1. I've got a 1 in front of pi. Here, n is 3. I've got a 3 in front. So Bn, that's going to be 4 over n times pi. And so we could actually say that f of x is equal to, now remember, a naught was 0, our constant was 0. So what we're going to do now is we're going to plug all of that in to this. Okay? All a1, a2 and all that was all 0. A naught was 0. So now I got to plug in my b terms. But see, the b2, that's 0. b4 is going to be 0. Okay, so I'm going to use b1, b3, and we'll go to b5 also. All right. So this is going to be, all right, so for the first one, that's going to be 4 over pi, okay, times what? Times the sine of x. It's b1 times the sine of x. Plus, now b2, that was 0, so that term's gone. And then b3, which is 4 over 3 pi times the sine of what? Now remember, n, in this case, n was 3. You see that? See, this is when n is 3, we got 4 over 3 pi. And you can see what we're doing here in the formula. See, b2, that's a 2. So if that's a 3, that's sine 3x. And then we could say 4 over 5 pi times sine 5x plus, and then dot, dot, dot. And, you know, come here and go ahead, 4x, factor out of 4 pi, just makes it look better. So that's going to be sine x plus 1/3 sine 3x plus 1/5 sine 5x plus dot, dot, dot. And this would be your answer. Okay, so you can see that the you can see they're pretty long, the problems are. All right, so let's look at the next one. I didn't write all the problems out in advance because I didn't know how much space I'm going to need for each one. All right, so here we go. So this problem here, it doesn't look bad, does it? Kind of looks like the last one we did, except right here we have an x, and boy is that going to make a difference. Okay. All right, so let's go ahead and find a naught. So now, you know, if I were you, go ahead, those formulas that I had at the very beginning in orange, go ahead and write those down so you got them right there by you while you're watching the video. All right, so I've got 1 over 2 pi, and that's going to be from negative pi to 0 of 1 dx plus 0 to pi plus 1 over 2 pi integral negative, come on, 0 to pi of f of x, so that's x dx. Okay, so this is going to give me 1 over 2 pi x from negative pi to 0 plus 1 over 2 pi, well, yeah, well, we'll do that, 1/2 x squared from 0 to pi. And so that's going to give me 1 over 2 pi times 0 minus negative pi plus, that's going to be 1 over, what is that, 4 pi times pi squared minus 0 squared. And so when we do all this arithmetic and all that good stuff, we get 2 plus pi over 4. And so that's a naught. Okay, so all I'm doing right now, I'm just circling my constant a naught and then my coefficients. Okay. All right, now let's find a1. Let's see what happens here. So from the formula up at the first, that's 1 over pi times the integral. That's going to be negative pi to 0. Now our function, remember, it's f of x times cosine. So that's 1 times cosine x dx plus 1 over pi, and that's going to be 0 to pi of our function times cosine x. So that's going to be x times cosine x dx. All right. All right. So now we've got 1 over pi sine x from negative pi to 0. All right. Plus, now we've got to integrate this thing. Okay, we've got to integrate this. So look, come on, go over to the side and do it. Let's see. What do we got to do here to integrate this? That's right, integration by parts. So I'm gonna let u equal x dv is cosine x dx. So du is dx and v is sine x. So that's going to give me x times sine x minus the integral sine x dx. So that's x sine x minus, okay, well, what's the antiderivative of sine? The antiderivative of sine is negative cosine. So the negative and negative are going to make a positive. So plus cosine x. So when we integrate this thing, this is what we get. And so that's going to be plus 1 over pi times x sine x plus cosine x from 0 to pi. Okay, so you know I had to do parts here. Go to the side, do it, get your answer, and then all I'm doing is I'm replacing all of that with what I got as my answer. Okay, that's all we're doing. And so this, hopefully you can see this whole term here is 0. Okay, the sine of 0 is 0. The sine of negative pi is 0. Okay, we'll go ahead and plug it in on this one. That's going to be sine 0 minus sine of negative pi plus 1 over pi times sine of pi plus cosine pi minus, and then we plug the 0 in, 0 times sine 0 plus cosine 0. I think that's it. I think I got everything plugged in. All right, but notice that whole term there goes to 0. And look at this. This term here goes to 0, and this term here goes to 0. So what are we left with? We're left with 1 over pi times the cosine of pi is negative 1 minus the cosine of 0 is 1. And so we're left with negative 2 over pi. And that's A1. Okay, there's A1. All right, so what I'm going to do now is we've got to find A2. So A2, and let's go ahead and just write the integrals out. That's negative pi to 0, and that's going to be not sine, That's going to be cosine x dx plus 1 over pi times the integral 0 to pi of x cosine x dx. All right. And look, when you evaluate that thing, you're going to get 0. Okay. It's going to be work just like this. It's going to be work similar to how we're going to do A3. We're fixing to find A3. Oh, I'm sorry. I wrote that formula wrong. This would be 2x. Okay. So it's going to be worked exactly like we did. I mean, it's going to be worked exactly like we're fixing to do A3, except we've got a 2 instead of a 3. Okay. The video is already going to be long enough. So just trust me on that one. It's going to be 0. Okay. All right. So now let's find A3. Trying to make that 3 look a little better. All right. So that's going to be 1 over pi from negative pi to 0. And that's going to be 1 times cosine 3x dx plus 1 over pi times the integral 0 to pi cosine 3x dx. All right. All right. So now, what do we have? Well, this is going to be, remember we talked about this, that's going to be 1 over 3 pi sine of 3x from negative pi to 0. All right. Plus 1 over pi. Now, let's go to the, I left the x off there. That's x times cosine 3x. Man, I hope I don't keep doing this throughout the video. I got a lot on my mind in this video, trying to point different things out to you, so you know it may happen. But you know, if I leave something off, you say, "Oh, I think there should be a x there." Well, yeah, and I'll catch it. Okay, but it's the function times cosine. So let's come over here. Let's take this right here and do parts. So I've got u equal x, dv is cosine 3x dx, du is dx, v, now what's v? That's 1/3 sine 3x. And so this is going to be x over 3 sine 3x minus 1/3, let's see, 1/3 integral sine 3x dx. And so this is going to be x over 3 sine 3x, and then the integral of sine is negative cosine, so that's going to be a plus. Multiply by the 1/3. 1/3 times 1/3 is 1/9 cosine 3x. All right. All right. So let's write that down. So I've got x over 3 sine 3x plus 1/9 cosine 3x, and that's going to be from 0 to pi. All right. So once again, look, if I plug the 0 and the negative pi in, this whole thing here goes to 0. Okay, just like it did up there in A1. Okay, and so this is going to be 1 over pi times, let's plug the pi in, pi over 3 times sine of 3 pi plus 1/9 times cosine 3 pi. I know that looks messy. That's sine. All right, minus, and that's going to be 0 over 3 times sine, plug the 0 in. That's 3 times 0 is 0, plus 1/9 times cosine 0. I need one more parenthesis. All right, so look at this. This term here goes to 0. This term here goes to 0. And so that's going to be 1 over pi times cosine of 3 pi is what? Cosine of 3 pi is -1. -1 times 1/9 is -1/9. Minus cosine of 0 is 1. 1 times 1/9 is 1/9. And so we're going to get -2 pi over 9. And there's your A3. All right. All right, now, look, all we've done is find the coefficients A. Now we got to do B. So let's find B1. So that's going to be 1 over pi, and that's going to be -pi to 0. And that's going to be what? Our function. So from -pi to 0, our function is 1. So that's going to be 1 times sine x dx plus 1 over pi, 0 to pi, and then our function x times sine x dx. All right. All right. So for this one, we've got to use not use substitution, but we've got to do parts. So let's integrate the first one first. So this is going to give us -1 over pi cosine x from -pi to 0. Integral of sine is negative cosine. So let's come over here and do parts. We're going to let u equal x, dv equal sine x dx. So du is equal to dx. V is negative sine is negative cosine x. And so this is going to be -x cosine x minus, but the negative here is going to make it a positive, and that's going to be cosine x dx. So this is going to be plus 1 over pi times, that's -x cosine x plus, what am I doing? You dummy. All right. So we've got the -x cosine x plus, now we got to integrate that. So that's going to be -x cosine x minus sine x. All right. No. Plus sine x. All right. Antiderivative cosine is positive sine. And so that's going to be plus sine x, and that's going to go from 0 to pi. All right. All right, so now plug everything in. So that's going to be -1 over pi times cosine 0 minus cosine negative pi plus 1 over pi times, and that's going to be negative pi cosine pi plus sine pi minus, and that's going to be -0 cosine 0 plus sine 0. All right. All right, so let's look at this. This is going to be -1 over pi times, that's going to be 1, let's see, 1 minus, so that's 1 minus, cosine of negative pi is the same thing as cosine pi. Cosine pi is -1, so minus -1 plus 1 over pi, and that's going to be times, all right, so we've got negative pi cosine pi, So that's negative pi times negative 1. That's negative 1. And then look, that's 0 minus, that's 0 plus, and that is 0. See that? And so we end up with, once you do all this arithmetic and all that good stuff, you're going to end up with pi minus 2 over pi. And that's B1. All right. Now let's find B2. And as I promised you, I'm going to show you an easier way. So let's look at this one. We've got 1 over pi, that's negative pi to 0, sine 2x dx plus 1 over pi, that's 0 to pi, and it's our function f of x, which is x, times sine 2x dx. All right. And, look, we did an example up here, integration by parts. We did the integration by parts here. Look, this is the same thing. This is integration by parts also. Okay? So what I'm going to do, this is going to be 1 over pi. I'm sorry. Yeah. All right. It's going to be 1 over pi. And I'm going to go ahead and write out what we would get when we integrate this thing. So when we integrate that, that's going to be negative 1 over 2 pi. And that's going to be cosine 2x. And that's going to be from negative pi to 0 plus 1 over pi times. And then when we integrate this using parts, we're going to get negative x over 2 cosine 2x plus 1/4 sine 2x, and that's going to go from 0 to pi. And when you do all that, when you evaluate and everything, you're going to get negative 1/2 as an answer. All right. Okay. So let's write our function. F of x is equal to a naught. Okay. We're using this up here at the very first, this thing right here. We're plugging everything into here. The A naught, the A1, the A2, the A3, B1, B2, B3, so on. Okay. All right. That's all we're doing. So we get f of x is A naught. And in this problem, look, A naught, well, that's way on up there, is 2 plus pi over 4. Okay. So that's going to be 2 plus pi over 4. All right. And then we've got A1. A1, where's A1? There's A1, is negative 2 over pi. So that's going to be minus 2 over pi. And that's going to be what? Cosine x. And then we've got, that's A1. Now A2, let's see. Oh, A2 was 0. So that term's gone. And then we've got A3 is negative 2 pi over 9. So that's going to be minus 2 pi over 9. And remember, this is A3. So that's cosine 3x minus ... Plus, now we got the B1. So B1 is this, pi over 2, pi minus 2 over pi. So that's plus pi minus 2 over pi. And that was B1. So that's times sine x. And then we've got minus B2, or plus B2, which is negative 1/2 sine 2x plus ... And this would be your Fourier series. Okay. Okay. Now, let's look at this problem here. Okay. Let's look at this. So we've got, we came up here and we found, look at this, we found A1, A2, and A3. And look at all the work we did. We had to integrate all that stuff there, okay? So you're probably thinking, well, there's got to be a better way, and there is. But I just wanted to go through that with you to do, basically to do a lot of integrals, so it's going to come easy to you. So we're looking for the coefficients, A1, A2, A3, so on. So instead of finding A1, plugging the 1 in for n and integrating, or A2, plugging the 2 in for n and integrating, or A3, plugging the n in and integrating, why don't we say, you know what, let's just find A sub n and integrate that. All right, so let's work all this out. So that's going to be 1 over pi. Okay, so this is still the same problem. What I'm doing is I'm finding A1, A2, and A3 in this same problem, but instead of finding them each individually, basically what I'm doing is I'm getting a formula for it. Okay, so instead of doing all this stuff that we did up here, finding them each individually, you can just come and do this. Okay, I wanted to show you both ways. Okay, all right, so we've got negative pi to 0, and it's the function, which is 1 times cosine nx dx, plus 1 over pi from 0 to pi, the function, which is x, times cosine nx dx. All right, so let's integrate. So this is going to be 1 over n pi. Okay, remember you got to multiply by the reciprocal of this coefficient of x, and that's going to be sine nx from negative pi to 0. Okay, all right, and then that's going to be plus 1 over pi times, now for this one we need to go to the side and do parts. So let's just come over here and do, all right, so we've got u equal x dv is equal to cosine nx dx. And so I get du is dx, v is 1 over n sine nx. Okay, and so we get x over n times sine nx minus, and that's going to be 1 over n times the integral sine nx dx. And so this is going to be x over n sine nx minus 1. Well, the integral of sine is negative cosine, so that's going to be plus, and we've got to multiply by 1 over n because of the coefficient. So 1 over n times 1 over n is 1 over n squared cosine nx. And so when we integrate that, we get x over n sine nx plus 1 over n squared cosine nx, and that's going to go from 0 to pi. All right. All right, so now let's evaluate this thing. So this is going to be 1 over n pi times the sine of 0. When we plug 0 in for x, that's just 0. And then we plug the negative pi in, so that's going to be minus sine of negative n pi. Okay, so that's the first one here. And then plus 1 over pi times, plug the pi in, that's pi over n times sine of n pi, plus 1 over n squared times cosine n pi minus, and now we got to plug the 0 in. So that's going to be 0 over n sine 0 plus 1 over n squared cosine 0. All right. All right. So it's going to be kind of easy here. Hit something with my hand. All right. So we got 1 over n pi times the sine of 0 is 0 minus. Now look at this. The sine of negative n pi. Okay. So remember, n is 1, 2, 3, 4, 5, 6, 7, and so on. Okay? So, what happens if I take the sine of 1 pi? What do I get as an answer? I get 0. I know it's a negative in front, but it doesn't matter. Okay? We've got minus sine of negative n pi, which, remember, this is the same thing as if we bring the negative angle identity. That's negative sine n pi, which is equal to plus sine n pi. That's from trig, your negative angle identities. So we can just look at finding the sine of 1 pi, 2 pi, 3 pi. Because see, n, that's what n's going to be. 1, 2, 3, 4, 5, 6, 7, so on. But does it matter what n is? The sine of 1 pi is 0. The sine of 2 pi is 0. The sine of 3 pi is 0. The sine of 4 pi is 0. Doesn't matter. So that's just minus 0 right there. Plus 1 over pi times, all right. And so we just talked about it here. This, no matter what you got here, the sine of pi, 2 pi, 3 pi, 4 pi, 5 pi, that's 0. So 0 times whatever that is just going to be 0. Plus 1 over n squared. Now here, the cosine of n pi. That's something that's going to make a difference, because let's see, what if n is 1? What's the cosine of pi? The cosine of pi is negative 1. That's if n is 1. But what if n is 2? What's the cosine of 2 pi? Cosine of 2 pi is 1. So the cosine of pi is negative 1. The cosine of 2 pi is positive 1. What do you think the cosine of 3 pi is? Negative 1. What's the cosine of 4 pi? 1. So it's going to change depending on what n is. So we can't really do anything with that. We're just going to leave it cosine n pi. And then that's going to be minus. This term is 0. And then plus. And then what's the cosine of 0? Cosine of 0 is 1. So that's 1 over n squared times 1. And so it looks like, well, all of that's 0. That's gone. That's gone. So we've got 1 over n squared cosine n pi minus 1 over n squared. All right. Oh, goodness. Look what I left off. That should be a pi. Well, let's do this. Times 1 over pi. Just got so excited explaining all that to you, I forgot that 1 over pi. And so that's just going to be 1 over n squared pi cosine n pi minus 1 over n squared pi. And so that's it. That's n. That's a sub n. And, you know, I think we could even, I don't know, maybe do maybe do this. I mean, I guess if you wanted to, you could factor out a 1 over n squared pi. You don't have to. Let's just leave it like this. So there's a sub n. So look at this. a1, what is a1? That's 1 over 1 squared times pi times cosine of 1 times pi minus 1 over 1 squared pi. Well, what is this? That's -1, right? Cosine of pi is -1. So that's going to be -1 over pi, -1 over pi, minus what? 1 over pi, which is -2 over pi. Look at that. Let's go see what we got for a1 up here. Where is it? There it is. -2 over pi. See that? And then, you could go and find a2. Okay. So, a2, so that means n is 2. So that's 1 over 2 squared times pi times cosine of 2 pi minus 1 over 2 squared pi. So what does this equal? Well, that's 1, right? Cosine of 2 pi is 1. So that's 1 over 4 pi minus, look at that, 1 over 4 pi. What did we get? 0. What did we get for a2 up there? 0. And then a3, that's going to be 1 over 3 squared pi times cosine of 3 pi minus 1 over 3 squared pi, which that's going to be 1 over, well, -1 over 9 pi, because cosine of 3 pi is -1. -1 times that, and then minus 1 over 9 pi is -2 over 9 pi. And if you remember for a3, look at that. Got the same thing. Okay? So when you're working these, yeah, you can go find them all individually like that. Okay? You can find them all individually. But why? Why would you want to do that? You don't. Okay? So, find your a sub n, and then you can find your a1, a2, a3 pretty easy. Okay? But, the one thing about that is, you get up here and you find your a1, a2, a3. Let's say you make a careless mistake on a3, so you get a3 wrong, but you get the other two right. The thing about this, if you make a careless mistake here, every one of them is going to be wrong. Okay? So be careful when you're finding your a sub n, not to make a mistake. Okay? All right, let's look at the next example. All right, so this problem number 3 here, I've got f of x is equal to, that's going to be 1, 0, negative pi less than or equal to x less than negative pi over 2, and pi over 2 less than or equal to x less than pi, and this would be negative pi over 2 less than or equal to x less than pi over 2. Okay, we're not gonna work this one out. Just something here I want to show you. So if we find the Fourier series for this, that's going to be 1/2 plus 2 over pi times, that's going to be cosine x minus 1/3 cosine 3x plus 1/5 cosine 5x minus, okay? That's the Fourier series for that one, okay? No, I can't get up there and do that in my head. I didn't do that in my head. I worked it, got the answer, and now I'm just providing the answer for you, okay? So keep this problem in mind, okay? So for number 4, we've got f of x is equal to, that's going to be 1 from negative pi less than or equal to x less than negative pi over 2, and then pi over 2 less than or equal to x less than pi, and then 2 negative pi over 2 less than or equal to x less than pi over 2. Okay, so we went through all the grueling, tedious work to find this answer right here for this problem. Okay, let's just use our imaginations and say that's what we did. Okay, now notice this function here. This is 1 greater than this. This is 1 greater than this. This function, okay, are all 1 greater than the ones in this function. Okay? So what we would have here for our answer, okay, for our answer, oh, wait a minute. This, all of these are 1 greater than this. So that means the solution to this would be, we would add 1 to this solution. Okay, so that would be plus 1/2 plus 2 over pi times cosine x minus 1/3 cosine 3x plus 1/5 cosine 5x minus ... Okay, so you notice that all of these values are 1 greater than that. So all we're doing is taking the solution to this one, which is here, and adding 1 to it. And so this would give us f of x is equal to 1 plus 1/2 is 3/2 plus 2 over pi times cosine x minus 1/3 cosine 3x plus 1/5 times cosine 5x minus... Well, we'll just use a parenthesis, and there's your answer. So that was the point of these two examples, to show you to do that you could do that. Okay. All right. So we've got our last example coming up. But before we work our last example, I've got to write down some new formulas, so I'm going to pause the video to do that. All right, so let's see what we got here. So in the previous examples, all the examples we've worked so far, we've gone from what? We went from negative pi to pi, right? Well, what happens, and let me go ahead, and I'll go ahead and write the example down. So we want to find the Fourier series for, let's see, we got f of x is equal to, and that's going to be 0, 2, that's going to be -4, less than or equal to x less than 0, and then 0 less than or equal to x less than 4. All right. So we're not going from negative pi to pi. We're going from some number negative L to L. See? Negative L to L. And look, it's the same thing that you've been doing. Okay? Look, before we just went what? We went from negative pi to pi. Well, what happens if you plug pi in here? There's your 1 over 2 pi. Look at your formulas from earlier, from the very first formulas we had. Look at this one, 1 over pi. And that would be negative pi to pi. And L is what? L would be pi, pi over pi. The pi's cancel out, and that's where the nx came from. You see that? And so now, and that's the same thing here, and then our Fourier series would be a0 plus a sub n cosine n pi x over L, and then b sub n sine n pi x over L. And of course, your n here would be 1, 2, 3, 4, 5, so on. Okay, so it's basically the same thing that we're doing, except L is not pi anymore. Okay. All right. So let's look at, is that the problem I wanted? Hang on, let me see. Yep, that's the one we're doing. All right. So working this one, we've got A naught equals, okay. So we've got 1 over, now what is, in this case, do you see that L is 4? Okay, negative L to L. Okay, so that's 1 over 2 times 4. And then, and we've got to split this up again. That's negative 4 to 0. And the function here is 0 dx. That's nice. Then that right there just goes away. And then that's going to be plus 1 over 2 times 4, and that's going to be 0 to 4 of 2 dx. Okay. And when we do all that good stuff, we end up with, that's going to be 2x. So that's going to be 1/8 times 2x from 0 to 4, and that is just equal to 1. Okay, so there's a 0. Now let's find an. We're not going to go through and find a1, a2, a3, a4. We're just going to find an. So that's this formula, 1 over L. So that's 1 over 4. Now look, look, you're going to write this down. You don't have to, but look. Okay, negative 4 to 0, that's 0. Okay, that's just 0. So, if you want, don't even bother to write that one down if it's 0. Plus 1 over 4, and that's the integral 0 to 4 of, that's going to be 2 cosine of n pi x over 4 dx. All right. So that this integral here, that's just 0. So now we've got to integrate this. So the antiderivative of cosine is sine, right? And I tell you what, before we integrate, let's just go ahead and do this. Let's write this 1/2 0 to 4 cosine of n pi x over 4 dx. Okay, let's just go ahead and bring that 2 out. All right, so now let's integrate this thing. So that's going to be 1/2. The antiderivative of cosine is sine, but remember we gotta multiply by the reciprocal of the coefficient of x. So that's going to be 4 over n pi sine of n pi x over 4, and that's going to be from 0 to 4. All right. So this is going to give us, that's going to be 2 over n pi times, okay, so we got our 2 over n pi. That's going to be the sine. Now I'm plugging 4 in for x. The 4's are going to cancel out, so I'm left with sine of n pi minus, and then I plug the 0 in for x, so that's just the sine of 0. And if you remember, that's 2 over n pi. The sine of n pi, it doesn't matter what n is, it's 0. Sine of pi, sine of 2 pi, 3 pi, 4 pi, all that's 0. Minus 0, which a sub n is 0. Now let's find b sub n. Okay, so b sub n, that's 1 over 4 times the integral negative 4 to 0 of 0 times dx. I'm sorry. That's going to be 0 times, that's going to be the sine of n pi x over 4 dx plus 1/4 0 to 4, and that's going to be 2 sine of n pi x over 4 dx. And look, remember how I told you I would probably forget to write things down? I mean, just knowing that that's 0, I should have written that as cosine n pi x over 4 dx. Now, I forgot that it's the function times the cosine of that, which, I mean, I wasn't thinking about it because I just knew it was 0, okay? But I did remember down here. All right, so once again, that whole term, that goes to 0, okay? And so let's write it 1/2 0 to 4. What about, yeah, okay, 0 to 4, and that's going to be sine of n pi x over 4 dx. All right, so this is going to be 1/2. Now the antiderivative of sine is negative cosine, so that's going to be negative 4 over n pi times cosine of n pi x over 4, and that's going from 0 to 4. And so this is negative 2 over n pi negative 2 over, that's right, over n pi. Well, and let's clean this up. Cosine of n pi x over 4 from 0 to 4. And so we're going to get negative 2 over n pi times, and that's going to be cosine, plug the 4 in, that's cosine n pi, minus, and then plug the 0 in, that's cosine of 0. And so what do we get? We get negative 2 over n pi times cosine of n pi. We talked about that earlier. When n is odd, cosine is negative 1. When n is even, cosine's positive 1. And then that's minus 1. And I think what I'm going to do here, I got b sub n is equal to, so I think this negative sign here, I'm going to distribute that. So that's 2 over n pi times 1 minus cosine n pi. So I just distributed the negative, so that would be minus cosine plus and a positive 1 there. Okay. And so, and we're done now. So I can now find b1 is 2 over 1 times pi times 1 minus cosine pi, and that ends up giving me 4 over pi. And then for b2, that's going to be 2 over 2 pi times 1 minus cosine of 2 pi. Well, what's the cosine of 2 pi? Cosine of 2 pi is 1, so 1 minus 1 is 0. That's going to give us 0. And then b3 is 2 over 3 pi times 1 minus cosine of 3 pi. All right, so cosine of 3 pi is negative 1. 1 minus negative 1 is 2. And so that's going to give me 4 over 3 pi. And then b4, that's equal to 2 over 4 pi, right? 2 over 4 pi times 1 minus cosine of 4 pi. Well, cosine of 4 pi is 1. 1 minus 1 is 0. That gives me 0 as an answer. And so we have f of x is equal to 1. Probably forgot about a naught up here. Let's see our constant a naught, 1. And now we just have coefficients for b. So that's going to be plus 4 over pi times the sine of what? Now in this, remember, n is 1, so that's 1 pi x over 4 plus 4 over 3 pi times sine, and in this case n is 3, so that's 3 pi x over 4 plus dot dot dot, and that would be your answer right there. Okay, so you can see, yeah, these are long problems, but if you find a sub n, b sub n, and then plug in the 1, 2, and 3, or in 4, however many your teacher tells you to do, they're not that bad. Okay. All right. So I promise here, this is the last problem. I don't know if I even numbered this one up here. I just put it was an example. Let's do the same thing here. Example. All right, so here I've got f of x is equal to x squared, and that's from -1 less than or equal to x less than 1. So I don't have a piecewise function this time. Okay, no piecewise function. So let's do it. In this case, can you see that L is 1? Okay, so A naught is equal to 1 over 2 times L. L is 1, 2 times 1 is 2. And that's going to go from -1 to 1. I don't have to split this one up. This is it's not a piecewise function. And that's going to be the function dx. So that's going to be 1/6 x cubed from -1 to 1, which is 1/6 times 1 minus -1, or 1 cubed minus -1 cubed, which is going to be 1/3. So there's A naught. Okay. Now let's find A sub n. Okay. So that's 1 over L. 1 over L, so that's 1 over 1, which is just 1. Okay. And that's going to be the integral -1 to 1 of our function x squared times cosine of n pi x over L dx. All right. Oh, that's over 1. And so that's going to be -1 to 1 x squared cosine n pi x dx. So this is what we have to integrate. All right. So are you ready for the fun part? Here we go. We got to do parts. And when we do parts, well, what do you think we're going to do? Well, we're going to end up having to do parts twice on this one. Yeah, I know, but it is what it is. So let's dive into it. You're going to have fun. All right. So we're going to let u equal x squared dv is equal to cosine n pi x dx. So du is 2x dx. V, well, the antiderivative of cosine is sine, so that's going to be 1 over n pi sine of n pi x. And so now we get, that's going to be x squared over n pi times sine of n pi x from -1 to 1. Okay? Minus, all right, minus, that's going to be, let's see, what is that? 2 over n pi x from -1 to 1, x times sine n pi x dx. All right. All right, so we're getting there. Well, now we got to integrate this thing, so we're going to have to use parts again. And so let's just go ahead. We've got x squared over n pi times sine of n pi x from -1 to 1 minus 2 over n pi times this integral here. Okay? All right. So here we go. Let u equal x. dv is going to be sine of n pi x dx. du is dx, and v. All right. So what's v? Well, what's the antiderivative of sine? It's negative cosine. So that's -1 over n pi cosine n pi x. And so we have x squared over n pi sine n pi x from -1 to 1 minus 2 over n pi times, and so that's going to be -x over n pi, that's that, minus, okay, oh, I'm sorry, let's see, hang on, okay, all right, so -x over n pi cosine n pi x minus, now the minus and this minus and this minus is going to make a plus, the integral, let's leave the constants out, that's 1 over n pi integral, oh, and this is going to be from -1 to 1, and then we got -1 to 1, and that's going to be cosine n pi x dx. All right. So now I've got x over n pi sine n pi x from -1 to 1. Now what I'm going to do here is I'm going to distribute this. Okay. So when I distribute that, I'm going to get plus 2x over n squared pi squared cosine n pi x from -1 to 1 minus, and that's going to be 2 over n squared pi squared from -1 to 1 cosine n pi x dx. So all I did was distribute the this number out here. That's all I did. All right, so now I've got x over n pi sine of n pi x from -1 to 1 plus 2x over n squared pi squared cosine n pi x from -1 to 1. And now I've got to integrate this. So the integral of cosine is what? Is negative, well, not negative, but the integral of cosine is sine. And so I've got to multiply by the reciprocal. So this multiplied by, see, I got to multiply by 1 over n pi. So that's going to give me minus 2 over n cubed pi cubed sine of n pi x from -1 to 1. All right. Now, let's look at this. This is where it's kind of nice for us. This whole thing goes to 0, and this whole thing goes to 0. Remember, we talked about it in the earlier problems. If you're having trouble understanding why that's 0, you need to understand it because it's going to make your life easier. Look, when n is 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry. When n is 1, 2, 3, whatever, the sign of that is 0 because we're at pi. You see that? We're at pi. Okay, so it doesn't matter. And same thing over here. So this is going to equal 2x over n squared pi squared cosine n pi x from -1 to 1. That's all we got now. That's what we have to evaluate. All right, so this is going to be 2 times 1 over n squared pi squared times cosine of n pi minus, and I tell you what, no, let's just leave it like that. And that's going to be 2 times 2 times negative 1 over n squared pi squared times cosine of, and plug the negative 1 in, that's negative n pi. All right. So hopefully everybody's with me now. Okay. So this is going to be 2 over n squared pi squared cosine of n pi. Now, look, you see this negative here, that negative and that negative make a positive. And so that's going to be 2 over n squared pi squared. And then remember, we talked about this earlier. Cosine of negative n pi is the same thing as cosine n pi. It's the same thing. So we can write this as cosine n pi. That's your negative angle identities from trig. Okay? Your negative angle identities from trig. So look at this. We get, no, we're finding, this is a sub n, not b. So we get a sub n, well, we can add those two together. That's 4 over n squared pi squared cosine n pi. Now, this, well, we can now find A1, A2, and A3. So A1 is 4 over 1 squared pi squared times cosine of, plugging the 1 in for n, 1 times pi. And A1 is going to be negative 4 over pi squared. Okay. Let's see. A2 is going to be 4 over 2 squared pi squared times cosine of 2 pi. And A2 is going to be, let's see, A2 is going to be 4 over 4 pi squared. And then A3, that's going to be 4 over 3 squared pi squared cosine of 3 pi, which that's going to be negative 4 over 9 pi squared. And I mean, we're already over an hour and a half into this, but look, Bn, you would do the same thing, but I'm going to go ahead and let you know you're going to get 0. Okay? So if you're sitting around bored with nothing to do, write it up and work it. Show that you get the b sub n is 0. Okay? All right. So now we get f of x is equal to a naught. Remember a naught up here. It's 1/3. And that's going to be minus 4 over pi squared times what? Now these are going to be cosine functions, right? And remember, L is 1. Remember, L is 1. So what we're doing is we're plugging that into here. Where is it? Oh, it's way on back here. See, L is 1. So it's just going to be n pi x over 1. All right, so that's going to be cosine. Now, this is when n is 1. This is a sub 1, so n is 1. So that's cosine pi x minus 4 over 4 pi squared cosine. Remember, L is 1, so there's not a denominator down there. That's going to be 2 pi x minus 4 over that 4 over 9 pi squared cosine 3 pi x minus dot dot dot. All right, so now we've just got f of x is equal to 1/3. Now what I can do here is I can factor out a negative 4 over pi squared. Factor out a negative 4 over pi squared. So that's going to leave me with cosine pi x. That's going to be, oh wait a minute, I don't know why I wrote a minus there. That should be a plus. See, that's positive. Minus, and that's going to be 1/4 cosine 2 pi x plus 1/9 cosine 3 pi x. And this would be your answer. And this next term here would be a plus instead of a minus. All right. All right. So, you know, there you go. That's all of this video. Okay. So I know there were times where at first I wrote something down wrong and caught it later on and changed it. But you know, it is what it is. It's a long video, tedious work. It's gonna happen. Okay. So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.